Welcome back everyone to our 3D world generation series. Today we're going to start adding some textures onto our fancy little cube here, so that we can have it looking a little bit nicer than just a white box. So let's get going. The first thing I want you guys to do is double check that you have your textures set up correctly. So just select all of them. A couple of settings you have to be aware of. Make sure texture type is default. 2D for texture shape. sRGB color texture will do. Alpha is transparent. Yes. Read write should be enabled. That's under the advanced dropdown. Generate maps should be on. Filter mode, if you're using pixel art, then point no filter, otherwise building. And then compression should be either none if you're using pixel art, or if not, then normal quality. And then press apply, and that will make your textures ready to be used. So what I'm going to do is create a block class, and our block class is just going to contain the textures used for every block, essentially. And then what we're going to do is we are going to have a script which reads the textures from every block that we've implemented, put them into a tile atlas, and then show them on the cube by sending the cube the tile atlas, and the cube's going to read and send each face a certain coordinate to read the texture from, essentially. A little bit confusing. Even I'm not 100% sure of how we're going to do that just yet. The first thing we want to do though is get going on creating the texture atlas. So let's create a new C# script. And first thing let's do is create the block class. So I'm going to call this block class. And our block class is going to be a scriptable object. So we can get rid of mono behavior. We can get rid of this generic line. We can get rid of this functions as well. And we're going to create an asset menu for it. File name can be something like new block class. And this file name is just the name that appears on the file by default. Doesn't matter too much because we're going to rewrite them anyway. Menu name can be, however, let's just name this block class. There we go. And this, to actually be used, needs a public string, and this is going to be block name. And then we're going to have a public texture 2D array. And this is going to be block face textures. Now these are going to be placed in the array in a special order. The order being front, back, right, left, top, and then bottom. It would be handy so that we could essentially memorize this, but since we're bad at memory, I'm just going to create a tooltip for us. And if you've never used tooltips before, they're very cool, and I'll show you how they work in just a sec. And put them here. Basically, it means that when we hover over the text inside the, similar how this gray box appears here, it's going to show this text, so we don't have to memorize it, which is nice and handy. Our cube is going to take in a public block class. And that should be fine, I think. We also need in our cube a public texture 2D, and this is going to be called texture atlas. And before we draw a cube, we also want to have a function called void draw texture atlas. Just like that. This needs double brackets there. Cool. And then we're going to call it here, we're going to draw texture. Well, let's say create texture atlas. And this is going to call draw texture atlas here. And draw texture atlas is basically going to draw up a whole texture based on the textures we provided inside each block class. Eventually, this will be done in a separate script for now, so we can keep things a little bit more simple. I'm keeping them in the same script, less data being passed around and stuff. It will make it easy for everyone to keep track of. Let's leave that here for now, the scripts. Let's create our first block class. So let's go to create, and we'll get this new tab pop up, block class. I'm going to name this grass. And now when we hover over this, we should get a little tooltip appear, maybe. Shall we? There we go, front, back, left. So we don't have to memorize this, which is very handy. Block name is going to be grass block for me there. And then I'm going to add a bunch of textures. We need 6 for each face, of course. So 0 to 5 will do. Front is that one. Back is normal side. Then another side, and then another side. And then the top is obviously going to be grass top. And the bottom is going to be dirt. Cool. That's our textures set up for grass. Let's drag and drop that into our block class slot in here. There we go. And when we initialize, we want to set our texture atlas to equal a new texture atlas of size texture atlas new texture. No, yes, new texture 2D. What am I doing? And we need to give it a width and a height. The width is going to be, of course, a certain width, which is the block class 0 dot block class dot block face textures 0 dot width times 6 because there's 6 faces. And we're going to do the same so we have a nice square texture for the height. Just like that. And I might declare that down here when we initialize the draw texture atlas. Like that. That should work, I believe. Yes. So now we just have to loop through each texture. So for int t equals 0, t less than 6 for each face, t plus plus. So each texture, we're going to loop through each axis. So for int x equals 0, x less than the texture's width, which is obviously this, x plus plus. And then we just have to do the same for the y-axis. So I can copy that, paste it, y, y, and y. Cool. Yes, that looks about right. X equals 0. X should equal t, I believe. Should be t times the width. So I'm going to create a float int width here. So int texture width. And that's going to equal this. It just saves me from having to write this massive line here each time, and that way I can just say texture width each time. Saves me a lot of effort. And then I'll add a bracket there and replace this as well. Add a bracket there. Cool. And then here I can say t times texture width, x less than t times texture width plus texture width. It will be, yes. So x less than t times texture width plus texture width. X plus plus for this, and then y less than, of course, texture width. And I should probably create another axis for this, but it is okay. I will rename this though to tx just to keep track of it a little bit better. Now we just have to set the pictures, set the pixels, and then at the end we have to apply the texture. Here we set the pixels. So when we apply the texture, that's super easy. We're just going to do texture atlas dot apply. And then when we set the pixels, I want to do texture atlas dot set pixel. And then pixel I'm setting is x and y. And the color I'm setting it to is going to be block class dot block face textures tx dot get pixel. And the pixel I'm getting should be x and y, I believe. Yes, this should be x and y, which means this loop is incorrect because this should start at 0 then. And x less than just texture width, which means then this bit won't work. So set pixel texture x plus texture width times tx and then y. Something like that. Let's run it and see what happens. Okay, so as you can see, something has happened. It's worked technically, but something is also going wrong here, where we're generating the texture gradually more and more, and we're also getting this blank column here, which should not be there. So let's figure out what's going on. Tx times texture width. This should be just texture width. Okay, that worked this time. Perfect. So as you can see, we have all our textures for that cube class right there. Obviously, some of the textures repeat, but that is fine because sometimes our textures might have different sides textures. In some cases, not all, but we'll just act like it does. Now we just have to find a way to pass in this texture into the UVs of the cube, which in theory should not be too difficult, but it probably will be. So the first thing we're going to do is make sure we apply the texture to our mesh. So after we set the mesh, I want to do get component renderer dot material dot main texture equals texture atlas. So that way our game object actually uses the texture we've created, and then all we have to do is just map the UVs. Does it work? Material instance, the albedo is set. Yes, cool. So that's it. That's that part done. So now for each face, we just have to map the UVs, which is quite easy because on the x-axis, they're all going to be, so every single front face is the same, just the y-axis changes depending on the order in which the texture is that block class. So the block class is going to determine on which position of the texture atlas it is on the y-axis. But the x-axis, every front face texture is going to be in the same column, and every back face texture in the same column, etc. So it makes our life a little bit easier when we apply the UVs. What I'm going to do is say UVs dot add, and this is going to give us a vector2 item. So I'm going to say new vector2. And the first one we're going to add is, of course, vector2.0. So that's what I'm going to do. I'm going to say vector2.0 because our front face is, of course, first. And then on the y-axis, we want to say our vector2 to vector2.1 times, and we should multiply by texture width. In that case, let's make texture width a global variable. So I'm going to put that up here. Private int texture width. And then I can just stop doing that there. Yes, cool. And then here I can just say multiply by texture width divided by 6, I think. Divided by 6. Is that right? It would be 6 divided by texture width, I think. Yes. What I'm going to do is just stop generating all my other faces, just so I can test this properly for now. And then this will be vector2.1 times that. Vector, not 1, should be up. And then it will be up plus right. So it would be vector2.1, yeah, and then it would be vector2.right. Okay. I think something along those lines. Let's find out. Either that or it's just not showing anything. So if I multiply that by texture width, that would show me the full texture for that axis, and then I'd have to divide it. I would have to divide it by texture width times 6. And the reason I'm doing times 6 is because that's the height that we're making our texture at. It is times 6 here. So I'm going to divide it by that height. And that's because UVs have to be set to a percentage between 0 and 1 of the full texture. And this math will allow us to hopefully obtain that. There we go. So we have one full texture generating. Success. So that's good. I think we've done it right. Yes, I'm gonna copy that. First, I'm gonna add a comment saying add UVs, and then I'm gonna copy that over to our back face. Just there. There we go. And this should now say vector 2 dot right, and then it will say vector 2 dot right times texture width times 2, because this is the second texture. Is that right? No. Vector 2 dot up. Look, realistically, we could just do the first one because they do share the same texture. I think I might do that. Side textures, since in majority cases they're all going to be the same, what I'm going to do is just have all our side textures are the same. So top and bottom can be different, but it's going to be side, top, bottom, and same for these, side, top, bottom, because we don't need a front, back, left, right, blah, blah, blah. In literally every case that's coming to my mind now, the sides are the same, like tree trunks and everything, yeah. So that's what I'm going to do, side, top, bottom. That is fine. We'll have to set that again in our thingy. In fact, let's do that now. Let's do things one by one. So now grass, once this recalculates, right, we just need to get rid of these extra side textures here. There we go. So it only takes up 3 textures. The first one being the side, right? Side, top, bottom. Yeah. Okay, cool. That worked. Fantastic. Back in our cube, I want to do, rather than times 6, we can do times 3. And then that means for our front face and our back face and all our other side faces, they can add the same UV coordinates. So we can save from calculating that. Makes our life a little bit easier. Save that. Cool. Bottom and top are going to be different. Let's just set the right one as well. And then let's set the left one as well. Very nice. That worked. Let's uncomment out all these side faces because now we know they work. For our draw textures function, this should now, I think, work as well by default. It says tx less than 6. This should be tx less than 3. Well, it should realistically will do block class dot block face textures dot length. If I run that now, we should have all the side face textures done. They are not done. Yeah, so it's only reading that first half. Because we should have an integer holding that. Yes. So we'll have another private int, and this will just say num textures. And num textures is what's gonna be, because yeah, I've got each time we multiply by 6 here, this should be num textures. Cool. And I'm gonna go ahead and do all of that for all my other faces, and then I will be right back. So as you can see, I'm still going. Just renaming all my, well, redoing, just changing the 6s to num textures. Should have done this from the start to be real, but it is what it is. That should be fine there. In here, I just want to say num textures equals this block class dot block face textures dot length. And then here, I want to say num textures. Well, it's less than that, yeah. Okay, cool. That should now fix our UVs. They indeed do very nicely as well. Cool. It was a little bit of a hassle. Let's just do our top face textures now as well. We don't need this anymore. Let's uncomment this one out. So our top face is the second texture in the list. So let me just copy our UV paragraph as well, again, from just one of these functions. Here we go, add UVs, Control C, minimize that, and then paste that here, Control V. So add UVs, it's going to add, this time it's going to add vector 2 dot right. So it's going to add this one first. Then it will add this one, they're the same. Yes, it will be 1. Okay, and then it will be vector 2. In fact, maybe shall we do this way? New vector 2. This will be 1, 0 times that. And then this one will be new vector 2, 1, 1. And then it will be 2, 1, I think. Yes, Control C. We don't need this extra bracket there. Yeah, it will be 2, 1. And then 2, 2. If my calculations are correct. Okay, so we're rendering our top face. Let's run this and see what happens. Okay, so something is off. Most of it looks okay. It looks like our second triangle seems to be off. Okay. 2, 0. Yeah, there we go. Okay, so now we've got the grass top working. Okay. My bad. I put one of the UV coordinates off. Okay. Nice. All right, let's do the bottom one. And then we're done with texturing. Oh, God. All right, let's copy the one from the top. Control C. Paste it at the bottom. Cool. Control V. Nice. And this one is going to be not 2, 0. It's going to be, yes, it's going to be not 1, 0. It's going to be 2, 0. And then it's going to be, go to 1, 2. No. 2, 1. 2, 0, 2, 1. And then this one's going to go to 3, 1. And then 3, 0. Grand reveal, it worked. All right, nice. We have a textured cube generating, finally. It was a hassle and a half. All right, so finally, we've got textures working as well. We've got cubes generating. Well, we have a cube generating. That's what we're going to do next episode. We're going to have cubes generating. So we're going to move a lot of the stuff to do with textures into another script, into the chunks script. And then the chunk is going to render the UVs and the textures and all that. So this cube class is going to become its own separate class, not a mono behavior. So next episode is going to be a lot of moving data over. That's it. Thanks for watching, guys. I'll catch you in the next one. Take care and peace.